Thank you, and thank you everyone for being here and for attending my talk. And I hope you've enjoyed it as much as the conference, as much as I have. I remember when we started this conference way back 2018 or so. We're just very interested to see, like, okay, who's going to show up and what's going to be the thing. So it's been very fun with all the things that we've seen, learned, and all the different use cases and what's happening. So today I want to focus a little bit about what we can do better, in the sense that what are we having as common issues? How do we tackle those? What are the misconceptions, and how do we work with those? So this will be the most common pitfalls. And I've been doing this for 8 years in terms of helping users use RabbitMQ in the best possible way. I try to help people all over, just not in CloudAMQP support, but also in other forums too. So let's start with the common issues and what we can see there. So usually in common issues we have what's called the server issues. So things happening on the server that the client feels is not optimal in one way or another. And this can be some resource that's out or saturated, disks or network, CPU, memory, etc. Could be a noisy neighbor. It could be a partition that's happening. But then on the other side, we have the so-called client issues, where the client is misbehaving one way or another. And there you'll see things like prefetch counts, or not using ACKs or not using confirms, using the wrong queue types, using wrong settings in the client. Maybe there's some missing reconnection logic. Maybe you're on an outdated client. The client has received an update that you're not using, so that there is bugs. And of course, these they have a mapping between the two. Like, some things happen in the client causing something on the server. If there's already a bad state on the server, it will reflect in what the client can do. This is not a complete mapping of how the issues occur. And usually the operator will see, oh, that's a developer issue. The developer needs to fix this thing. And the developer say, well, that's an operator issue. The operator needs to fix this for me. And if you're like a startup, you're maybe just one person, you are the same one. You are the developer, you are the operator. And then you're like, okay, I need to get this fixed. So I'll go through pretty quickly just some of the most common ones. And then we'll look into the misconceptions. So relatively often, the client is having a unbounded prefetch or a very large prefetch, or sending or receiving very large messages. And failure mode that happens here is that, okay, we'll process some of the messages, then I'll say, okay, this one, I can't process it. I'll put it back in the queue, and then you'll have this redelivery of this bad message, basically a poison message. This bad state can be exaggerated by having a high prefetch count. There are some things that can prevent this issue. In core MQs, you have a delivery limit. You can also set the max message size, and this max message size is going down in 4.0, so it will be 16 megabytes, or it is 16 megabytes. It's configurable, so you can change it up or down as you want. There's a default prefetch that you can set for clients that don't have a prefetch. In 4.1, there's a histogram coming, so you can see the histogram of messages, what the message size is, depending on which protocol it's using. And in 3.13, there was a nice bug fix where if you're restarting, rebuilding the queues, and you had a big message, 40 megabytes, it would not be able to rebuild on a 1 gigabyte RAM machine. But now you can load even the biggest messages on startup, so that's very good. Common issue is not using the optimal queue for whatever it is that you're doing, or not the optimal configuration, or not the optimal protocol. So as we heard about here, there's some features regarding the flow control in AMQP 1.0. There's also probably just as common issue is that you don't fit the matrix of durability and persistence. So you're using a transient queue with persistent messages, or you're using a durable queue with transient messages, and then you ask, oh, why did I lose messages on restart? Well, it's because that's what someone said at the moment. This is a issue that's being phased out. Quorum queues are by default persistent, and the messages to them are too. So we'll see less and less of this issue, and we'll see less of the flow control issue with AMQP 1.0. Common issue is all forms of churns and all forms of leak. So the churn is especially bad because it's an expensive operation. Expensive for the Erlang virtual machine, and it's relatively expensive on the operating side too, with all the packages that needs to go back and forth. The worst case is if okay, let's not go to the worst case, but let's think about what we can do about it. For the connection churn, you can limit it on the operating side. You can set a you can rate limit the number of connections you can do per second. You can set limits for maximum number of connections, maximum number of channels, maximum number of queues. And if your client has to do this, like PHP client, you can use a proxy, and there's a new feature there that it can support pooling of connections. And a common case here where there is an issue that kind of goes back and forth between the developer and the operator is if you have disk or RAM exhaustion, the client will say, oh, I can't publish. And then it will open a new connection, try to publish, and it say, oh, I can't publish. And it just goes on and on and on. Disks. This is what ChatGPT generated for a very a big rabbit. So the disk is the cheapest resource that you over provision. Disks today are relatively cheap, but a lot of times people think of the disks only as the space they provide. They also have limits on number of operations you can do per second. It also has limits on what bandwidth you have. And especially if you're sending bigger messages, you'll run into the limit that the bandwidth is limiting you. The good news is in today's world, most clouds can dynamically add more space or bandwidth or IOPS. and you don't need to stop Rabbit or the machine, but you can do that on the go. So you can do the things when you are seeing that queues are getting backed up. Unfortunately, it's hard to go the other way around. To shrink the disk, it's a more involved operation. And I'll talk a little bit more about the Watermark in just a second. So switching gears to the misconceptions. So it's slow, can't handle the throughput of some other system. It will, if I just scale out, I will increase the performance. The support for some of the other protocols is not there. And disk memory alarms will pause publishers. Well, yes, that one is actually, I shouldn't have that in quotation marks. And all queues should be of this certain type. Sorry, yes. Okay, this misconception that it can't handle the throughput of some other system was maybe true 2018, but now with streams and improved queues, we don't have the same problem. So you can partition stream and you can receive those million message per second workloads that you might want to use. And sometimes using a log for storing messages just pushes the complexity to somewhere else. So yes, I published it on the log, but do I know if I have read the log? Okay, I'll do another log just for saying that I've read the log, and now you like reinvented the wheel there. So this is the IBM Pollyanna principle that machines should work and people should think. And I say, no, queues should work and people should think. Scaling out increased performance. Not really. So relatively often people say, okay, I will just change my 3 nodes to 5 nodes and then things will be better. And no, unless if it's a partitioned stream system, yes, if the performance that you're measuring is number of connections that you can keep, yes, if you're spreading them out, but usually not otherwise. Your latency will not be better just because you have more nodes. And this is a Warren Buffett quote related to that you can't produce a baby in 1 month by getting 9 women pregnant at the same time. Okay, AMQP 1.0 and MQTT support. So we heard the talk from David earlier today about AMQP 1.0 support, and we already verified it with a customer that had issues in 3.13. Upgrading it to 4.0 made those bugs go away. There is a talk from last year about the MQTT support, and there is some asterisks, but mostly the MQTT support is much better in the later versions, much more like integrated than it was before with a plugin. And one of the things that was an issue earlier on with getting Rabbit connected to, for instance, for Service Bus was creating this connection URL for the shovel. And there is a, if you scan that QR code, that helps you with that setup. And so that's very good to have. All metrics, or metrics in general, are free. It's good to monitor and using Grafana and all these things, but if you decide to monitor everything all the time, you will end up generating multi-megabyte chunks of data that needs to go through the system every 15 seconds, etc., or every 5 seconds. So once you have thousands of something, exchanges or queues or connections, if you try to get all the details for all of them all the time, you'll end up with those big chunks of data that in itself creates a hiccup in the system. And maybe the worst you can do there is collecting all that and then just filter out one single field, queue name and number of messages. Then you've done so much work for very little benefit. Let's talk about the watermark and the alert. The disk or memory alert will pause publishers. It's true, but there are some corner cases which can make this not true. So one of those is shovels or exchange federations, queue federations, which will keep on publishing even if you have a watermark. You can use the HTTP API still, even if there's a watermark. And dead lettering scenarios can keep on going even if you have this. And then I left a question mark, which more are there? And just think about it and I can discuss it. I left out at least two that I can think of and see if you can find which ones those are. Okay, everything should be of the same type. No. So first, if someone is using classic mirrored queues, then listen to the previous talk, help you migrate. There are known issues. For quorum queues, great in general, but you need to think about the if you have very long queues or very many queues, thousands of queues, then and also not suitable for large fan-outs. If you have large fan-outs, then you can use a stream queue, and if you're using classic mirrored queues without the if you're using classic queues without the mirroring part, then you can keep very long queues for very little cost in terms of CPU, in terms of RAM usage. And you can still have high speeds, but you don't have that replicated part. So just to final thought, with all the flexibility in RabbitMQ, there's also some responsibility, and it's a shared responsibility between this developer, this operator, and you just have to think a little bit how you use all the features. Do you really need to use all the features? Do you need to use all of them at once? So yeah, thank you.
So much. Okay, questions?
Hi. In the big messages section early on, you mentioned that there is like upcoming histograms for message size per protocol.
Yep.
Can you describe a bit more about those? What kind of metrics do we get?
It's a Prometheus metric that will bin messages, and you can see then, okay, in AMQP 091, this is the distribution of message sizes.